we have some fresh images of 3I Atlas, the third interstellar object ever observed from Earth, racing through our solar system. Astronomers captured this moment live, aiming Chile's Gemini South telescope at the comet in late August. They anticipated confirmation of a faint visitor shedding dust and ice as it drifted closer to the Sun. What they witnessed instead was something unsettling. The comet's tail had transformed. Once a hazy plume, it now stretches outward like a luminous spear, sharp and massive, glowing more intensely. The press release described it politely as significantly more extended, but that phrase hides something remarkable. This was no ordinary chaotic tail, it was growing with precision, almost as if it were under control. It pointed toward a path that would soon take the comet terrifyingly close to Mars. Normal comets don't behave this way, their tails form when solar heat sublimates frozen gases in the nucleus. This process releases jets of vapor and dust, while the solar wind passes that material outward. By nature, comet tails are messy, twisted, and scattered depending on changing solar conditions. However, 3I Atlas looks different. Its tail wasn't a smeared haze, it was broad, clean, and sharply defined. Instead of random jets puffing unpredictably, it stretched like an exhaust tail, lengthening stage by stage. This behavior was anything but simple for a comet born in another star system. It raised the question no one wanted to voice aloud: was this just sublimation, or was it something more? Harvard astrophysicist Avi Loeb even suggested the tail could be functioning like thrust, a controlled exhaust. This would mean it was not merely the chaos of melting ice, but rather the signature of propulsion. The mystery deepened when NASA's James Webb Space Telescope added its data. Webb's instruments detected an immense plume of carbon dioxide around the comet, stretching 350,000 kilometers in space. For comparison, that is nearly the distance between the Earth and the Moon. Yet, even at that size, the plume didn't behave like expected cometary exhaust. Scientists quickly calculated that the pressure of the solar wind should have confined the plume much sooner. Instead, the gas expanded further than models predicted, remaining too short to explain how material could reach Mars. In other words, the plume was both too large to be normal and too small for what might have occurred during the flyby. Outgassing like this usually makes a comet wobble or drift unpredictably, but Atlas' orbit remained sharp. Its fine-tuned path appeared locked in, like a guided trajectory. The CO2 told two stories, one of violent activity and another of unnatural stability. Then came the most shocking revelation yet. Avi Loeb's studies revealed that the nucleus's unusual brightness wasn't caused by nitrogen ice. Instead, it was reflecting sunlight because its surface contains nickel, not just traces, but concentrations matching industrial alloys. This kind of material is used for spacecraft, machines, and plating, not typically found on icy bodies between stars. No observed comet has displayed this kind of metallic coating before. Nickel is tough, resistant to coercion, and highly reflective, explaining why the nucleus shines brighter than models predict. However, the stability is precisely the problem. A natural cometary core should fracture, tumble, or wobble under outgassing. Instead, 3I Atlas appears locked in place, as though reinforced. This discovery has quickly become known as the nickel mystery, fueling suspicion that it may not be a comet at all. Could it be something built, a machine disguised in the trappings of a comet? Attention then shifted to the nucleus, the frozen core at the heart of the comet. Hubble had already estimated it could be anywhere from 1,000 feet to 3.5 miles wide. Ground-based telescopes suggested something larger, possibly over 12 miles across. That discrepancy is staggering. If it were only a mile or two wide, the nucleus should appear faint. Instead, it reflected light at levels inconsistent with its supposed size. If it were closer to 12 miles across, its mesh should make it wobble as jets of gas escaped. Yet, the trajectory looked unshaken, as though the nucleus were both brighter than expected and more stable than physics allowed. All of this might be dismissed as strange, but natural, if not for what happens next. On October 3, 2025, 3I Atlas will brush past Mars at a distance of 29 million kilometers. That number sounds vast, but in space mechanics, it is a needle's eye. More disturbing is the calculated minimum orbit intersection distance, only 2.7 million kilometers from Mars' path. That precision is so fine, it makes astronomers uncomfortable. Interstellar comets should not pass this close to a planet by chance, their orbits are random. Yet, Atlas is threading through the solar system on a course so exact that it feels more than a coincidence. A dart thrown from another continent should not graze the edge of a bullseye across the ocean. Yet, that is exactly what this object is doing with Mars. Its high-rise camera, one of the most powerful ever sent into orbit, will capture images at 30 kilometers per pixel. That resolution could separate the nucleus from the dust cloud, revealing details never seen before on an interstellar visitor. But many are not just expecting to see ice, they are waiting to see whether the structure looks natural or carries fingerprints of design. If this comet makes even a small course adjustment in the weeks before October, it will break the last defense skeptics have. Outgassing cannot account for adjustments of 10 to 15 kilometers per second. Yet calculations show that such a change would be enough to bring Atlas directly into Mars' path. That kind of maneuver would not belong to a comet, it would belong to a craft. Theories have already spread about the glowing tail serving as a disguise. But what if it's more than that? What if it's a mask, an expanding halo meant to hide smaller objects inside? The dazzling gaze could blind telescopes, concealing probes that detach and travel separately. Loeb and his collaborators calculated that if a mini-probe had been released 30 million kilometers ahead of the comet, it could intercept Mars simultaneously. Earth telescopes cannot detect reflections from objects that small, especially under 100 meters in size. This means if probes are riding within or ahead of that tail, we would never know until HiRISE points its camera at the right place. That possibility has unsettled more than just scientists. Congresswoman Anna Paula Luna has publicly called on NASA to monitor Atlas aggressively. She urged that both the Mars Reconnaissance Orbiter and Jupiter's Juno probe watch the interstellar visitor closely. On a podcast with Loeb, she went even further, warning that the comet could release mini-probes toward Mars or even Earth. Her argument was simple: if there is even a chance that this object is technological, it is the government's obligation to inform the public. It is extraordinary to hear a sitting lawmaker speak in such terms, reflecting the unease growing around Atlas. If this were truly just another comet, no one in Washington would be talking about probes. And now, time is running short. On October 30th, 2025, Atlas will swing past the Sun at its closest approach. Days later, it brushes by Mars, a comet blazing across the skies of two planets at once. If natural, it will be one of the most spectacular sights in modern astronomy, a chance to study an interstellar body up close. But if unnatural, if HiRISE captures structured objects, probes, or maneuvers, then this will mark something entirely different. It would signify the first clear evidence of non-human technology moving through our solar system. For now, all we can do is watch its tail stretch further and brighter against the stars. A glowing signal from another star system becomes sharper and more defiant with each passing week. When HiRISE turns its lens on October 3rd, we will finally know what kind of messenger it is. Until then, the comet blazes forward, its tail growing longer, its course unwavering, and its mystery deepening. And humanity is left to wonder, are we watching ice melt in the void, or staring at a machine disguised as a comet approaching Mars with purpose? Drop your thoughts in the comments, and if you want to follow this mystery all the way to its Mars flyby in October, make sure you subscribe. Hit the bell so you don't miss the next update.